Hello everyone. Welcome to this series on computer applications. This series is specially designed for students following the ICSE curriculum prescribed by the CISCE Council, New Delhi. We'll be covering key topics and concepts as outlined in the official syllabus, explained in a simple, practical, and student-friendly way. We are going to continue with Java arrays. What we have already done in the previous video or videos is definition of an array, types of arrays, declaration, initialization, accepting data of single dimensional arrays, accessing of elements of single dimensional arrays, arrays as composite type, that is an object, and the length statement to find the size of the array. What we are going to do today is the search techniques, linear search and binary search. The ICSE syllabus specifies techniques using single dimensional arrays only. What is a search operation? A search operation aims at looking for a value, a variable in a number of values, that is an array. So that means we are looking for a variable in an array. So array contains a number of values and a variable contains a single value. It normally results in a true or false situations. That means true means it's a found situation and false means it is a not found kind of a situation. The ICSE syllabus talks about the use of the following search techniques, that is the linear or the sequential search, and second is the binary search, and we'll do both of these today. First of all, we'll talk about the linear search. Linear search is done when we are looking for a value in an array containing unsorted values, and it is quite time consuming. Real life examples are looking for a word in a novel, so there is no shortcut way of finding a word in a novel. And secondly, looking for a news item in a newspaper. The search operation or this search operation will involve reading the entire book from the start to the end looking for the word. There is no shortcut. If the word is found anywhere in the book, the process stops. We don't need to continue any further because we have all we wanted to know was whether it is there or not. If the word is not in the book at all, you will come to know of it only when you have read the entire book. So not before that. Now, what is the basic concept of a linear search? The basic concept is you start the program by creating a Boolean variable with a false value. So why a false value? Because we have not found it yet. This variable will store the status of found, that is true, or not found, that is false. And why does it have a false in the beginning? Because we have not found it yet. We call this variable a flag. A flag stores a status, and status can be either a true or a false. So naturally, we will be using a Boolean variable for it. Then after this variable is created, we go through the entire array from the index 0 to the last index. You know the standard loop. That means we started x with x is equal to 0 and x is less than m dot length if m is the name of the array. And we compare the value of each element with the value we are looking for. That means each element is compared with the value we are looking for. And if the comparison is good, they compare okay, then we store true in the flag variable and exit the loop. So the loop is exited. When the loop exits, so we try to figure out what is the value. If the value is true, we display found, because if in the loop it has actually found it to be if it was found, so the boolean variable will have the true value. So if it is true, we display found, otherwise we display not found. Now the linear search program looks like this. We start off with the main function. In the main function, we start off by creating three variables. Basically, one is a variable containing a 3 and one is an array containing a number of values, and these are unsorted values. You can see that these are unsorted values, and there is a variable called x that has been created here. All right, and there is a boolean variable created which is false in the beginning. So I have highlighted those, and those are created as false. Now the standard loop is created here. The standard loop, that is x is equal to 0 to x is less than m dot length and x plus plus. And what is the loop doing? If it is basically, we check with using an if, we check whether mx, that means any position of m, if it is equal to n. First of all, x will be 0, it will check m0 is equal to n, then m1 is equal to n, then m2 is equal to n, and so on. If any of those is true, it will actually it will actually change the value of found to true. Earlier it was false. So in the loop we make it as true and we give the command break. So that means the loop is exited. So when the loop exits and found is found to be true, if that condition is true, it will display the value n was found, otherwise it will display the value n was not found. Let us see the program in running. There is a correction here. I had put braces here, here and here, which is not okay. Okay, so that was my mistake. Okay, so you don't need any braces here because there is a single statement inside and my else was a misplaced else here. Let us see the linear search. The same program again, whatever I have just copied it from there only. So Boolean found is taken as false, and we start the loop from beginning till the end. If the number is found at any of the positions, then found is changed to true, and break statement is executed. And once the loop exits, whether found or not found, it will check after the loop. It will check whether found is actually true. So if it is true, then it displays the value was found. Otherwise, it will display the value was not found. And let us run the program. It says the value 3 was found. And if I actually change the value of 3 to a 13 maybe, which is actually not found, and when I run the program again, it will say the value 13 was not found. Next, we come to binary search. Binary search is a little complicated. Linear search is simple. You just go from the beginning to the end. You keep looking for values, and if the value is found, then you just simply change the value variable found to true, and you exit the loop. That's it. Binary search involves looking for a value in a sorted array. In a sorted array now. The real life examples are looking for a word in a dictionary, and looking for a phone number in a phone directory. All these are arranged. So that means in a phone directory, the phone numbers are arranged. In a dictionary, the words are arranged. And looking for your result in a list sorted by roll numbers. For example, if in a gazette you are looking for your result and the gazette contains 10,000 results, you can easily look for your roll number. Why? Because it is sorted by roll number and you can simply figure out where your roll number is. Let us take the example of a dictionary. Let us take the example of a dictionary. We can divide the dictionary into two parts. Because of those two parts, we call this process as a binary search. Binary actually means the base of two, right? So we are dividing the dictionary into two parts. We look for the word in the middle page. So the middle page probably is words starting with M. And suppose I'm looking for something with starting with M. It is mother or motherland or something like that. So if we have found the word, if the word is there, we have found it. Then we can stop looking for the word. You can exit the loop now. Otherwise, we try to figure out whether the word is in the right part of the dictionary or the left part of the dictionary. And we can easily figure out why, because I know I'm looking for zoology and I'm on the middle page and the middle page contains words with M. So that means the word that I'm looking for, it must be on the right side of the dictionary. So I can discard the left half. So if a dictionary contains 1000 pages and I am looking for the word in on page number 500, you on the first search I can discard 500 pages on the left hand side. So that means I don't have to look for 500 pages now. I now have to look for only on the 500 pages on the right hand side. And now we calculate the middle of the rest of the part. So that means if the dictionary is 1000 pages, now out of the 500, I will go to page number 750 and figure out is my word there. I will show you the logic of this program now and we can figure out. Okay, let us discuss the logic for binary search now. Uh, this is the search variable. I'm looking for the variable n that contains a number 48. I've just taken a number 48. I have an array containing 10 numbers and those 10 numbers these are the positions, and the positions are 0 to 9. You should know this. And the values are 12, 23, 25, and you can see these are all arranged. If this was not arranged, I would not have been able to perform the binary search. Now the variables that I'm using, we already know that we will be using two variables. One is n, that is the variable, and one is the array m, that is the array. Now we will be using three variables: low, high, and mid, and this is the variable that we used in the previous program also. See, and it is doing the same thing as previous one. So I have three variables called low, high, and mid. Low, high, and mid. Low will always contain the position of the lower part of the array where I am going to start the search from. And high will always contain the highest position where I am looking for. So that means I am actually looking for the number in this entire array, and this entire array has starting position 0. So I put 0 in the variable low, and this array has the highest position 9. I put 9 in the variable high. Now we calculate the mid position. How do we calculate the mid position? The mid position is calculated by mid is equal to low plus high divided by 2. So low plus high divided by 2. Okay, let's consider low plus high divided by 2. That means 9 plus 0 divided by 2, it becomes a 4.5. And if I have taken these variables as int variables, they will not contain a 0.5. Naturally, mid will contain a 4. So that means if low is 0 and high is 9, the mid is calculated as 4. This is my middle of the dictionary, if you can, if you remember the example that I had used. We try to look for the number on this position. What is number on this position is 44. Is this 44 equal to 48, the number that we were looking for? No, it is not. Now we need to figure out whether my number 48 is on the right side of this array or of this mid or left side of this mid. Now because 48 is greater than 44, it must be on the right side of this. So where could it be found? It could be found in 5, 6, 7, 8, 9 positions, right? So what do? If the number is on the right side of the array, we change 0, we remove this value and we change this to this value. So that means it actually becomes a 5. Why 5? It becomes mid plus 1. Alright, mid plus 1. I am not using mid again as the part of the range where I'm looking for, because mid we have already discarded. It is not on mid, so why should I keep mid in the number at all? So I say mid plus 1. So low now has changed to 5 and high has changed, high is already 9. What would the mid now be? It is 9 plus 5, which is 14, divided by 2 is 7. So 7 is my mid now. Is this 48 present on this 7 position? No, it is not present on the 7 position. So what do? Now, the ranges on the left hand side are 48 and 55, on the right hand side is 65, 71. Now you know that 48 is less than 59. So what do? We change high as mid minus 1. So high actually changes to 6, and this is removed. Shall we calculate the mid again? So mid again would be 5 plus 6 divided by 2, which is actually 5.5. It will actually going to be treated as 5 because of the integer positions. Have we found it on this position? Yes, we have found it. Alright. I hope this part is clear. I'll just take another example. We shall start again. And when we start, we again have, now we have a number 25 that I'm looking for. The low and high and mid positions in the beginning are going to be 0 and 9, and mid is calculated as 4. Is this the value that I'm looking for? No, it is not the value I'm looking for. Then it must be on the left hand side. So we'll say high is equal to mid minus 1, where it becomes a 3. and it is not here anymore. Now mid is now calculated as 3 plus 0 divided by 2, which is actually a 1. So 1. Is 25 present on position number 1? No, it is not. Is it greater than 23? Yes, the number 25 is greater than 23. So low changes its position from 0 to mid plus 1. So always understand then that low will always be equal to mid plus 1, and high will always be taken as mid minus 1. Okay. So this is the variable called low. Okay. So we are going to take this as a 2. So the low becomes a 2 and it doesn't remain here. Mid is now calculated as 2 plus 3 divided by 2, which is actually a 2, and it doesn't remain here anymore. So this is the mid position. Is it now on the mid position? Yes, the number is on the mid position. We change the value of found to true, and that's it. And the loop finishes. Now let us take a value which is actually not present in this list at all. Let us see what will happen now. 43. Okay, we have taken 0 and 9 as low and high. The mid is 4. Is 43 present here? No. Then because it is 44 is less than 43 is less than 44, we change the value of high from 9 to mid minus 1. You can see that we do this. Okay, so mid minus 1. So high does not remain here, and low is now recalculated. So 3 plus 0 divided by, that is a 1. Okay, is this present? Is 43 present on position number 1 on mid position? No, it is not present on the middle position. Then is it greater than? Yes, it is greater than. So low changes from 0 to 2. It is not this anymore, and this is now changed from this to a 2. Why? Because 2 plus 3 divided by 2 is a 2. Is 43 present on number 2? No, it is not present on position number 2. So is it greater than? Yes. Low becomes mid plus 1. So low becomes a 2. Sorry, low becomes a 3. And this is not there. And this mid is now also calculated as 3. Because low is 3, high is 3. So divided by 2 is 3. Is now 43 present on position number 3? No, it is not present on position number 3. What do we do now? Is because 43 is greater than 34 and it must be on the right side. So we change the position of low to mid plus 1. It becomes a 4. Now, did you notice that the low has actually gone beyond high? Low was supposed to be the lower part of the range. It is now has gone beyond high. So when low is greater than high, I should stop the process now because it is not going to be found at all. Low should always have a value less than or equal to high. Then it is possible to find. Otherwise, it is not possible to find. So what is the condition of this loop going to be? The condition of this loop is going to be while low is less than or equal to high. Now please remember, I cannot use a for loop because I don't know how many times I'm going to look for it. Because middle can go anywhere in this array. So, and it could be found in the first instance itself. If the number was 44, it will be found in the first loop itself. So I don't know how many times it is going to execute. I simply say while low is less than or equal to high, this should go on, otherwise it should stop. Alright, let us write the program for binary search. How the program will look like, not exactly the program but the logic for it. We create a variable called n in the beginning, and we create an array. They are given some values. They are could be fixed values. Normally in the board exams they give fixed values because they are supposed to be sorted. We can't expect the user to give a sorted input to the array, or we could input by the user. So that doesn't matter what. Low is given is initialized with 0, and high is initialized with the last index. And normally last index is normally m dot length minus 1. We start off with a loop, and the loop is while low is less than or equal to high. We have discussed this earlier. We calculate mid as low plus high divided by 2. So when uh, whatever is the value of low, whatever is the value of high divided by 2 will be the middle position. Now we check the value whether the value at the middle position, that is m mid, is the same as n. If this is the same as n, that means we have found it. And we change the value of found to be true and found to true, and we come out of the loop, we give the break statement. Otherwise what do we do? We need to figure out whether it is now the number is on the right side of the array or the left side of the array. So what do we do? We check whether n, the number that I'm looking for, has a value greater than m mid. So that means if it is greater than m mid, it is not in the left side. So that means this means the value can no longer be found in the left part of the array. So we shift low to mid plus 1. We had discussed this earlier. Otherwise, this means it is not on the same as n. It is not greater than so and so. Then it must be less than. So it must be on the left side. So if it is on the left side, we shift high to mid minus 1. So that means high is now given a value of mid minus 1. And this is the end of the loop. So the loop goes back again. A middle is calculated again. Now again it checks whether the middle position is the same as n, and then again if it is found, that is okay, it comes out of the loop. Otherwise it checks whether n has a value greater than. If it is greater than, change low as mid plus 1, otherwise change high as mid minus 1, again end of the loop. Now when the loop finishes, we do exactly the same thing that we did in linear search. We check whether found is now found to be true. If found has a true value, we say yes, it was successful. Otherwise, we say no, it was not successful. Okay, we'll work on the binary search program now. In the binary search program, I have kept the parts of the linear search that were the same, but I have removed everything else. So I've taken n as 55, which I'm looking for, and these are the numbers which are already arranged. I don't need the x because I'm not using a for loop. I'll create my variables low, which is going to have a value of 0, and high, which is going to be having the value of m dot length minus 1, and we are having a variable called mid. I'm not going to calculate it as yet now. Let us start the while loop now. Found is already false, fine. So I'll say low is less than or equal to high. I have explained it to you when we were doing the logic. Why is low less than or equal to high? Low should always be less than or equal to high. So the first thing that we do in the loop now is calculate the value of mid. So mid is equal to, I say, low plus high divided by 2. So standard. Now we check whether n is equal to m mid or m mid is equal to n. So it's the same thing. So if this is the case, that means we have found it now, and I will change the value of found to true, and I will give the break statement. So that means it is now going to exit from the loop. But if it is not found, what do we do? We now change the values of low or high depending on where it is now going to be found. So we now check else if n, the number that I'm looking for, is it greater than m mid? That means now if it is greater than m mid, naturally it is going to be found on the right hand side now. What do we do? If it is going to be on the right hand side, so I change the value of low to mid plus 1. Else, now I don't need to check any condition at all. Why? Because I already know if it is not equal to, if it is not greater than, it must be less than. So I'll say high is equal to mid minus 1. That's it. The program is done. The program is done. So we take the array and the number that I'm looking for. We create found as false in the beginning. We have variables low, which is having a value of 0, high having a value of mid m dot length minus 1, that is the last index, and a variable mid I am not calculated yet. In the loop, condition is basically low is less than or equal to high. The moment low becomes greater than high, the program should actually stop. So what do we do in the beginning? We calculate mid, which is low plus high divided by 2, and we check whether it is found. Then if it is they are equal, then it must be found. Found is true and it actually breaks. If it breaks and found is found to be true, it will display the value n was found. Otherwise, it displays value of n was not found. Now, by the way, if it is not equal, then it checks whether the number I'm looking for is greater than the middle position wala number. If it is greater than, then low is shifted to mid plus 1. Otherwise, high is shifted to minus 1. And it goes back to the loop and does the calculation again. And when we run this program, it says the value 55 was found. Let me change this now to say instead of 55, I make it 51. It will not be found now. Let us now compile this program and run this program. It will say the value 51 was not found. So I hope the program of the binary search and linear search are clear to you. Okay, let us consider doing this program. This program was actually has been taken from the board exam paper of 2010. So this is the actual board exam paper question. So this says write a program to perform binary search on a list of integers given below. So they already give the numbers to you. You don't need to worry about that input. To search for an element input by the user. So that means whatever we are looking for, that n variable is actually input by the user. If it is found, display the element along with its position. Otherwise, display the message search element not found. So there is now a little variation of whatever is going to be the output right now. So if it is found, display the element along with its position. Otherwise, display the message search element was not found. In the program, I have put the numbers that we were actually supposed to work on. So I put the numbers there. I have not put any value in the variable n because I'm going to ask the user for it. And if I'm going to ask the user for it, I need the scanner class object. I say scanner sc is equal to new scanner system dot in, and I need to import also. So I need to say import java dot util dot I can just work with scanner. Now I need to input the value. Okay, so I need to say system dot out dot print please enter the search number or whatever you want to say there. Okay, and I can say n is equal to sc dot next end function. That's it. Okay, the numbers are 579. So let me look for a 15 now. So let me run the program. Let me look for a number 15. If I say 15, it will say the value 15 was found. And if I now search for any other number, say 67, probably it is not there. So it will say the value 67 was not found. But the program actually said I should display the position also. So how do I display the position? So n was found at position, and the position naturally is going to be mid. I will naturally find it at the mid position. So let us look for it. So let me just look at the numbers again. So let me look for a 45 and an 11 now. So mid. So why does it say that? Okay, mid has not been given a value. So let me give it a value. Otherwise it will say it has not been given a value. Let me run the program with an 11 and it will say the value 11 was found at position 3. Let me look for a number say 45. It will say the value 45 was found at position 7. That is the mid position. I hope this is sufficient for you to understand the binary search and the linear search. If you have any problem, you could write in the comments below and I'll answer. Please subscribe to this channel and share this video. Thank you so much. I'll see you in the next video.